There are enough things in this life to worry about, like nuclear war, climate change, and whether or not you're brushing your teeth correctly. The Earth spinning too fast should not be high up on your list, simply because it's not very likely to happen anytime soon. And if it does, you'll probably be too dead to worry about it. Nevertheless, we talked to some experts to see how it would all go down. Let's start with the basics, like, how fast does the Earth spin now? That depends on where you are, because the planet moves fastest around its waistline. As Earth twirls around its axis, its circumference is widest at the equator. So a spot on the equator has to travel a lot farther in 24 hours to loop around to its starting position than, say, Chicago, which sits on a narrower cross-section of Earth. To make up for the extra distance, the equator spins at 1,037 miles per hour, whereas Chicago takes a more leisurely 750 miles per hour pace. The Earth does change pace every now and then, but only incrementally. This summer, for instance, it skimmed 1.59 milliseconds off its typical rotation time, making June 29th the shortest day on record. One hypothesis is that changes in pressure actually shift the planet's axis of rotation, though not to the extent where regular human beings could feel the difference. Little bumps aside, if the Earth were to suddenly spin much faster, there would be some drastic changes in store. Speeding up its rotation by 1 mile per hour, let's say, would cause water to migrate from the poles and raise levels around the equator to by a few inches. It might take a few years to notice it, says Witold Fracek, an analyst at ESRI, a company that makes Geographic Information System, GIS, software. What might be much more noticeable is that some of our satellites would be off track. Satellites set to geosynchronous orbit fly around our planet at a speed that matches the Earth's rotation, so that they can stay positioned over the same spot all the time. If the planet speeds up by 1 mile per hour, then the satellites will no longer in their proper positions, meaning satellite communications, television broadcasting, and military and intelligence operations could be interrupted, at least temporarily. Some satellites carry fuel and may be able to adjust their positions and speeds accordingly, but others might have to be replaced, and that's expensive. These could disturb the life and comfort of some people, says Fracek, but should not be catastrophic to anybody. But things would get more catastrophic the faster we spin. Why does the Earth rotate? To answer this question, we must return to the time when our solar system first began taking form. At the very beginning, our solar system was composed of a massive cloud of dust and gases. Once the cloud began to collapse, it flattened into a giant disk with a bulge in the center, which eventually formed the Sun. As the planets and other celestial bodies, for example comets, asteroids, and moons, started taking shape apart from the original disk, the overall angular momentum of the disk needed to be conserved. Hence, these heavenly bodies inherited their rotation from the overall movement of the solar system. Without any unbalanced forces in play, nothing that we presently know of, the inertia of the Sun and the planets have maintained the mutual spinning for billions of years. Furthermore, they will continue to do so for billions of years until they collide with some other object. You would lose weight, but not mass centrifugal force from the Earth's spin is constantly trying to fling you off the planet, sort of like a kid on the edge of a fast merry-go-round. For now, gravity is stronger, and it keeps you grounded. But if Earth were to spin faster, the centrifugal force would get a boost, says NASA astronomer Sten Odenwald. Currently, if you weigh about 150 pounds in the Arctic Circle, you might weigh 149 pounds at the equator. That's because of the extra centrifugal force that's generated as the equator spins faster combats gravity. Press fast forward on that, and your weight would drop even further. Odenwald calculates that eventually, if the equator revved up to 17,641 miles per hour, the centrifugal force would be great enough that you would be essentially weightless. That is, if you're still alive. More on that later. Everyone would be constantly jet-lagged. The faster the Earth spins, the shorter our days would become. With a 1 mile per hour speed increase, the day would only get about a minute and a half shorter, and our internal body clocks, which stick to a pretty strict 24-hour schedule, probably wouldn't notice. But if we were rotating 100 miles per hour faster than usual, a day would be about 22 hours long. For our bodies, that would be like daylight savings time on boosters. Instead of setting the clocks back by an hour, you'd be setting them back by 2 hours every single day, without a chance for your body to adjust. And the changing day length would probably mess up plants and animals, too. But all this is only if Earth speeds up all of a sudden. If it gradually speeds up over millions of years, we would adapt to deal with that, says Odenwald. Hurricanes would get stronger. If Earth's rotation picked up slowly, it would carry the atmosphere with it. And we wouldn't necessarily notice a big difference in the day-to-day winds and weather patterns. Temperature difference is still going to be the main driver of winds, says Odenwald. However, extreme weather could become more destructive. Hurricanes will spin faster, he says, and there will be more energy in them. The reason why goes back to that weird phenomenon we mentioned earlier. The Earth spins faster around the equator. If the Earth wasn't spinning at all, winds from the North Pole would blow in a straight line to the equator and vice versa. But because we are spinning, the pathway of the winds gets deflected eastward. This curvature of the winds is called the Coriolis effect, and it's what gives a hurricane its spin. And if the Earth spun faster, the winds would be deflected further eastward. That effectively makes the rotation more severe, says Odenwald. Water would cover the world. Extra speed at the equator means the water in the oceans would start to amass there. At 1 mile per hour faster, the water around the equator would get a few inches deeper within just a few days. At 100 miles per hour faster, the equator would start to drown. I think the Amazon basin in northern Australia, and not to mention the islands in the equatorial region, they would all go underwater, says Fracek. How deep underwater, I'm not sure, but I'd estimate about 30 to 65 feet. If we double the speed at the equator so that Earth spins 1,000 miles faster, it would clearly be a disaster, says Fracek. The centrifugal force would pull hundreds of feet of water toward the Earth's waistline. Except for the highest mountains, such as Kilimanjaro or the highest summits of the Andes, I think everything in the equatorial region would be covered with water. That extra water would be pulled out of the polar regions, where centrifugal force is lower, so the Arctic Ocean would be a lot shallower. At 100 miles per hour faster, the equator would start to drown. Meanwhile, the added centrifugal force from spinning 1,000 miles per hour faster means water at the equator would have an easier time combating gravity. The air would be heavy with moisture in these regions, Fracek predicts. Shrouded in a dense fog and heavy clouds, these regions might experience constant rain, as if they'd need any more water. Finally, at about 17,000 miles per hour, the centrifugal force at the equator would match the force of gravity. After that, we might experience reverse rain, Fracek speculates. Droplets of water could start moving up in the atmosphere. At that point, the Earth would be spinning more than 17 times faster than it is now, and there probably wouldn't be many humans left in the equatorial region to marvel at the phenomenon. If those few miserable humans would still be alive after most of Earth's water had been transferred to the atmosphere and beyond, they would clearly want to run out of the equator area as soon as possible, says Fracek, meaning that they should already be at the polar regions or at least middle latitudes. Seismic activity would rock the planet at very fast speeds, like about 24,000 mph. And over thousands of years, eventually the Earth's crust would shift too, flattening out at the poles and bulging around the equator. We would have enormous earthquakes, says Fracek. The tectonic plates would move quickly, and that would be disastrous to life on the globe. How fast would the Earth spin in the future? Believe it or not, Earth's speed is constantly fluctuating, says Odenwald. Earthquakes, tsunamis, large air masses, and melting ice sheets can all change the spin rate at the millisecond level. If an earthquake swallows a bit of the ground, reducing the planet's circumference ever so slightly, it effectively speeds up how quickly Earth completes its rotation. A large air mass can have the opposite effect, slowing our spins a smidgen like an ice skater who leaves her arms out instead of drawing them in. The Earth's rotation speed changes over time, too. About 4.4 billion years ago, the Moon formed after something huge crashed into Earth. At that time, Odenwald calculates our planet was probably shaped like a flattened football and spinning so rapidly that each day might have been only about 4 hours long. Thanks for watching. To stay updated on the latest discoveries, make sure to subscribe to my channel and turn on notifications.